Now that you know how to work with rational expressions and equations, let's look more closely at the graphs of rational equations and look at and interpret some of the characteristics of a rational equation graph. Make sure you have your calculator on and you can follow along with every step. The nice thing about a video is that you can always pause and rewind to review. So make sure you are able to do on your calculator what I am doing here, and also that you understand these concepts. First, let's graph the rational function f of x equals x minus 3 over x plus 2. So go to the Y editor button at the top left of your graphing calculator, click on it, and enter the function as I am doing here. Make sure you encapsulate the numerator and denominator in parentheses so the calculator knows that these expressions are all part of the rational expression. Once you have this in the Y editor, click on the graph button at the top right to see the graph of this function. If your graph does not look like mine, then maybe your window is different. I have graphed in the standard window, so you should click on the zoom button at the top middle and the number 6 for the standard window. Now that you have the graph, let's examine some of the unique characteristics of a rational function graph. Notice that the graph comes close but never touches the vertical line that is x equals negative 2. We can see this by using trace to find y values for certain values of x. For example, x equals negative 1.5, the value of y is negative 9. And for x equals negative 1.9, the value of y is negative 49. So the closer you get to x equals negative 2, the more negative the value of y. And on the other side of this x equals negative 2 line on the graph, if you put in negative 2.5 for x, the value of y is 11. And for x equals negative 2.1, the value of y is 51. So in this case, the closer you get to x equals negative 2, the larger the value of y. If you put in negative 2, there will be no value for y, as I have shown here. This vertical line, x equals negative 2, where the graph approaches but never touches, is called the vertical asymptote. Can you tell me why the graph never has an x equals negative 2? Remember the restricted values for a rational expression? You can never have a 0 in the denominator because that would give you an undefined number. So in this case, you cannot have an x being equal to negative 2 because that would give you a 0 in the denominator and thus an undefined number. So on your graph, we call this a vertical asymptote. You will find that this asymptote will be important in applications of rational functions. But you will also notice that the graph approaches but never touches y equals 1. This is because as the positive value for x gets very large, or the negative value for x gets very small, then the minus 3 in the numerator and the plus 2 in the denominator do not affect the x very much. And the number is very close to being just x divided by x in this case, which is 1. This is called a horizontal asymptote, and these will be significant values as well when working with applications of rational functions. In this graph, there is also an x-intercept. We can find it by using the 0 function in the calc menu above trace. So go to second trace and click on 0. Now place your cursor to the left of the x-intercept and hit enter. Then move your cursor to the right of the x-intercept and hit enter. Now move your cursor to approximately the point of the x-intercept and hit enter. The calculator has identified the x-intercept for you as the point 3, 0. That is because when x equals 3, the numerator becomes 0. And 0 divided by any number is 0. Therefore, y is 0, and that makes this point an x-intercept. There is also a y-intercept. Using trace and x equals 0, we find the y-intercept is negative 1.5. Intercept points can be very significant points to interpret in an application problem as well.